Assalamualaikum, my name is Muhammad Muzammil bin Abdulin, and today I would like to present on the FSG 671, which is my final year project, which is the spectroscopic properties of europium ions and samarium ions co-doped magnesium borotellurite glasses. These are the content that we are going to go through in this presentation, which is the introduction, literature review, methodology, result and discussion, and also conclusion. So the objective of this research is to prepare the composition of tellurium oxide, boric acid, magnesium oxide, europium oxide, and also the samarium oxide with different concentration by using the melt quenching technique. And secondly, to investigate the physical properties such as density, molar volume of europium and samarium ion co-doped with magnesium borotellurite glass system. And the third one is to determine the influence of samarium oxide concentration on the structural properties of europium doped borotellurite glass using XRD and FTIR spectroscopy. And lastly is to determine the optical properties of europium and samarium ions co-doped magnesium borotellurite glass using a UV spectroscopy. So the problem is there is no further research has been done on the dopants with magnesium borotellurite glass, and also no research has been made on the physical, structural, and optical properties of different composition of europium oxide and samarium oxide ion co-doped with magnesium borotellurite glass. So for the background of the study, glass is an organic solid that has usually transparent and translucent, as well as hard, brittle, and resistant to the elements. And the method of melt quenching technique is widely used due to its dopants properties on the variation ion that make it uncomplicated to be prepared. And tellurite glasses were chosen as the best host material because of their appealing qualities such as high linear and non-linear diffractive index, low phonon energy and melting temperature, and great thermal conductivity stability. And lastly is combining this composition of tellurium oxide, boric acid, magnesium oxide, europium oxide, and samarium oxide in one glass system that can enhance the stabilization and the quality of glass. So let's go through into the literature review of physical properties, which is the first part is density. Each sample and chemical composition density is measured by Archimedes principle, which is the formula below, which is WA is the weight of the glass in the air, and WTW is the weight of glass when immersed in distilled water of density. And distilled water is used as it does not react chemically with the sample. And below is the example of another article or journal written by Akasha et al. 2019, which is the glass composition on the density, and given that the result is the density of the glass increase as the europium concentration increase. So for the next structural properties, which is the molar volume, that can be calculated by using the formula Vm is the volume occupied by 1 mole of chemical element or chemical compound is equal to the m is the molecular weight and divided by the density of the glass sample. And below is the example of another research that has been written by Spectroscopy et al. By using the glass composition of glassy alloy and resulting the molar volume of the sample increase at is derived from the atomic density. This is another structural properties that have been made on the FTIR spectroscopy analysis, which is written by Thomas et al. 2017 on a glass composition using a CN triple bond and CC triple bond, which is result of triple bond absorption appear at 2200 and 2300, which is a nitrile and alkyne that are usually medium to the weak intensity appear as a triple bond absorption during the infrared spectrum analysis on the glass. And the last structural properties that have been used is XRD, which is the X-ray diffraction spectroscopy. The XRD can analyze the amorphous structure and crystalline phase of the glass sample, which is we can see below the author from Tekin et al. 2020 by using the glass composition, which is result in broad diffuse scattering at low angles, which is 228 degrees. The explanation for this result is long-range structural disorder is visible in the XRD pattern, which is typical of amorphous network. So for the literature review on the optical properties, we are using the ultraviolet visible spectroscopy. The function of UV is to compare the intensity of light passing through the glass sample. UV VIS also can measure the absorbance and transmittance of the glass sample. As you can see below is an example from another research which is written by Naswa et al. By using the glass composition below, the optical band gap can be seen. The result of direct optical values and indirect electro-optical value increase respectively. So for the methodology, these are the glass composition that we are gonna use in this research, which is the tellurium oxide, boric acid, magnesium oxide, europium oxide, and especially the variation of samarium oxide on the composition, which is from 0 mole percent to 2.0 mole percent. As you can see up here, which is a sample preparation in this research, which is the first one is weigh the chemical for tellurium oxide, boric acid, magnesium oxide, and also europium oxide and samarium oxide using the analytical balance. And then it will be mixed with a chemical sample by milling procedure for about 1 hour. And then the sample will went through the melting process in electrical furnace for about 30 minutes at 1000 degrees Celsius. And then it will went through to the annealing process at 300 degrees Celsius for 3 hours. And then the sample has been cooled down to be ground, cut, and polished for the sample characterization such as density, molar volume, XRD, FTIR, and also UV VIS for the structural and optical properties. So for the characterization, the equipment and machine that have been used in this research is density and molar volume, which is the electronic density meter MD300, and for the UV we use Perkin-Almer lambda 35 UV spectroscopy, and for the FTIR characterization we use Perkin-Almer spectrum 100 FTIR spectroscopy, and lastly for the XRD we use Pananalytical Aspect Pro XRD. So let's jump into the result and discussion. These are the samples that has been prepared in this research, which is by using the glass composition that I mentioned earlier on the tellurium oxide, boric acid, magnesium oxide, europium oxide, and the variation of samarium oxide by melt quenching technique. As you can see here, the result is the glass color changed to more yellowish and shiny as the mole percent of samarium oxide increased. This is due to the transmittance that has been occurred in the band gap in the glass sample. These are the result of density and molar volume. From that, we can plot the graph for density, which is on the different concentration mole. From the graph, we can say that the density of glass increase as the samarium concentration increase. The same goes for the europium with the glass density elevates as the samarium oxide concentration increase. So from the result that has been shown in the table, the molar volume has been plotted into the different concentration of mole percent. Same goes to the density. The molar volume increase as it derived from atomic density, which correspond to the increasing concentration of samarium oxide.